Hello and welcome to another video for my vintage electronics channel, and this series of videos I'll be repairing and restoring a Stella ST234 radio from the late 1950s. I don't know how it's going to turn out. It may be a complete bust, but let's see how I get on. Here is the radio. It's quite compact. It's about 14 inches wide, and I wanted a valve-based VHF radio to go in my home office space so that I could listen to most days. I don't think this is a particularly sophisticated radio. It looks to be fairly simple, but it's got a VHF channel, long wave, medium wave, and a gram input at the back. It's just a single speaker. It's quite a small speaker there. The case overall is in good condition. And this is really the start of the process, is the visual inspection. Quite a few controls. I think this is volume. I'm guessing this is tone. This is definitely a selector switch. A bit stiff, but it does work. We have the tuning, so that looks to be all intact. So yeah, it's a fundamentally simple radio. Now Stella is a British company. I think they traded between 1951 and 1966, and they reused Philips chassis. So although it's a British company, it's definitely a Philips chassis in there. And I think the 234 is based on, got my notes here, the model 253A radio, but I'll just confirm that. So I couldn't find the schematic for the Stella directly, but I certainly got the schematic for the Philips version, the 253A. So let's just have a look at the back now. Here we are at the back. It's in good condition, the case here. I bought this from a charity shop, and it's been under the bench for about 18 months. I've not really got around to working on it. The Bush VHF 64 has taken a lot of time. And I think I paid about £10 for it, or £15 for it. It was posted. Paid about £6 for the postage. It arrived intact. There is a small piece missing out of the case here. Now that wasn't in the box, so that's obviously happened before. So that's something that needs to be addressed and repaired. So we're just looking at it there. So I'll be learning a few techniques to repair this. I have done Bakelite repairs before, but I want to try and improve my skills, so that needs to be addressed. That's certainly for one thing. What I'll do, I'll just get the back off, and we'll just have a peer inside there. Quick inspection of the back. It looks all complete apart from the output valve there. And first thing is, I can confirm from the drawing that the radio is in fact a 353 Philips chassis. So it's good that I've got the schematic there. The usual dirt inside. Can't see any wax dripping from the transformer, so I'm hoping that's in a good state. The speaker actually looks really good. It's larger than I thought it would be, actually, the speaker. All the coils are there, all the other valves are there. I can't really see any corrosion. So that, on the initial inspection, that looks really good. I believe there should be an inspection plate on the base. And that's what we do have. So I'll take that off and have a look to see what's going on under there. That'll give me an idea of what capacitors need to be changed. As routine, I do change the electrolytics in these. I don't try and reform them. And also the any wax paper capacitors. I do test those. I test every single component that comes out. Wax paper capacitors leak a lot, and I think I've had about 100% failure rate on those. Maybe one or two have been okay, but I've changed hundreds now. Fundamentally, everything along the wax paper line is faulty and needs changing. So there we are. What I'm going to do now is probably just get the chassis out and have a closer inspection. Now that I am sure that this is a Phillips 353 chassis, I can have a closer look at the circuit diagram. I think I'll do that now, actually. So looking at it, and this is a good service manual, actually. It's quite clear in terms of what we've got. So we've got lots of reference voltages on here. This will be the FM stage down here. So this will be the EF80 valve in its two stages. This being a separate box. Then it goes into the ECH81, which has I guess that's the first RF amplification stage, and actually that same valve for the FM will be the first IF stage as well. So it looks from this circuit diagram that we have a single IF stage for the AM, and we have two IF stages for the FM. Probably keeps the cost down of this radio, puts it in more of the commodity budget range, really. So, but we'll see what the sound quality is like. Some of the valves here are actually common with the Bush radios I work with. So EF80 I've not worked with. ECH81 I've got spare valves of those. They're quite very common in the Bush radios. And the EF85 I've not worked with before. EABC80, that's the detector for the AM, and also performs, works with the FM discriminator as well, and it forms the first audio amplification stage. I've got spare ones of those as well if I need them. EL84, I don't have a good spare one at the moment, but they're common in the Bush radios as well, and they're quite pricey, so but I will get an EL84 valve to go into the radio. EZ80 rectifier, I do have some spares of those. They're quite pricey, but luckily I've got some to hand if I need it. So I think I'm in good shape on the valves. On the basis I've worked with quite a few of these valves. I think there'll be quite a few similarities with the Bush radios, so we'll see how I'll get on. And what I'm going to do now, I'll probably get the base plate off and have a look inside the bottom of the chassis to see what sort of capacitors are in there. Looking in the bottom, it's actually very clean in here. I'm not really seeing any wax or wax paper capacitors, which is very encouraging. Obviously, there's a couple of electrolytics here. There's one there. I don't think there's an electrolytic. 100 microfarads. It's a low voltage one. And there's something in the back here which I need to do further investigation. These black ones. You can actually see the crack here, or the break in the case, so that will need to be repaired. What I want to do, I want to get the chassis out, so I'm not putting any strain on this case and making it any worse than what it is. First inspection looks, hopefully there might not be too much work to do. The chassis is nearly out the radio. It's just held in really by the speaker. So it was quite difficult to actually get out. The dial pointer sits in a recess, and the instructions say remove the dial pointer, but they don't. It's really difficult to see how. Actually, it's very easy because the cord is just wrapped around it, so it's just a friction binding, really. But I'm going to leave it in place now. So that was one tricky part of it. My initial thoughts about the chassis are the build quality is excellent. I'm used to working on British radios, mainly Bush Pi and Ferguson as well. I'm not saying they're bad, but in terms of the engineering, this just looks so much tighter in terms of the quality, high quality components. The layout is very, very good, very neat underneath in the chassis. And most of the capacitors are ceramic, so I don't think there's going to be much to change. I think there's 5 molded capacitors in there, which will have a paper dielectric, and they will probably be leaky, so I'll be changing those. And there's effectively four electrolytics. There's one in this large can. So the next thing I'm going to do is just give this chassis a good clean up, and we'll see what we'll get from there. That's the initial cleanup of the chassis. There's still some way to go, but it's a lot better. I'm happier to work with this now. So one of the first things I've noticed is the plate here. This is a plastic plate, sits under the dial panel, and I think that needs to be repainted. It's got cream paint on there which is flaking off, so I'm sure that's to help with the reflection. What I've also noticed that none of these wires are crusty in terms of the insulation. I don't know what material used, but everything's reusable, what I can see so far. The next thing I want to do actually is check the impedance on the mains transformer, or the let's just lift this up. What I want to do is just check the resistance on the mains transformer. Just get into view, and I just check in really for continuity on the windings. So I'm just looking for something that's a resistance but not dead short, and that's really encouraging. So that gives me a good idea that the windings are good. Let's just do this one here. I'm going to go to the secondary and do a similar thing. Try and get the contacts on there. Just making contact if I can. Yep. Oh, it was working there. Oh, slipped off there, and that is the secondary winding, so that's pretty good. So I'm pretty pleased with those. What I want to do now is do a similar thing on the output transformer, but what I tend to do is also put a signal generator on there just to test the transformer fully and kick the speaker into life. I've done some continuity checks on the output transformer, and I'm getting a decent resistance on there, which shows the windings are good. So I've now connected a signal generator to that transformer. So hopefully it'll test the transformer, kick the speaker into life. Just turn it on, and there we are. I hope you could hear that on the microphone. That's really a nice crystal clear tone. I'm really pleased. I just wonder how long that has been asleep and it's just sort of kicked into life now. It's just a fantastic thing. So my plan now is just to get the speaker out so I can release the case, and then work out what components I've got in stock and what I need to order to get to the point where I can power it up. Okay, I'm going to apply some power to the Stella radio. I've done lots of safety checks, and I've got a dim bulb in the system here with a variac to bring up slowly. And I know some people like to change the filter capacitors first, but I think as long as you've got the safety precautions in, you've done all the checks, then it's reasonable to power up slowly. I always like to hear the radio before any work's been done and after any work's been done. I've got a brand new, well, it's the second user EL84 valve installed. It is second-hand, but it actually looks almost new to me. Looks in great condition, so I'm pleased with that. So what I need to do now is just apply some power, and just bring it up slowly. So I know the dial on this variac's pretty accurate, so I'll be using that. That's up to 40 volts now. I'll do this very slowly. Up to 80 volts now. Nothing on the dim bulb, so that's encouraging. No lights, no filaments yet. And I believe I've got this set to medium wave, by the way. Up to 120 volts. Nothing yet. Up to 180 volts, and I can see the EL84 glowing, and a few of the filaments are coming alive. So again, I just wonder how long it's been since this radio has been powered. Always encouraging. And right, I'm going to leave it there. That's at 240 volts, and I'm getting some sound. I've got some dial lights actually working. That's really good. They're a little bit dim. Let's get a bit of volume there. Hopefully you can hear that. This background noise is normal for my environment here. There's lots of Wi-Fi equipment and cheap Chinese equipment that tends to emit lots of noise, so that's not uncommon.
Cold, you know, and you clearly outside, but they let it play on to see how it talks.
Well, that's really good. So that's Talk Sport, and that's coming through loud and clear, actually. And nothing on the dim bulb. Well, that's really loud. So that's really encouraging. So I don't think there's going to be much work to do to this radio. I want to try the FM now, so that's going to be my next task, to get an aerial in the back there and see if we've got any FM. I've got the dipole antenna plugged into the back of the VHF box, and I'm not getting anything on the VHF band at all. It's completely silent, so we've definitely got a problem there that needs troubleshooting. Right, that's the end of part 1, and if you do like these videos, then please do share and subscribe. I really do appreciate that, and I'll catch you in part 2 where I just carry on with the repairs.